definition of the derivative. We have 3 different formulas for finding the derivative. Those 3 formulas you need to know. They're fair game all the time. We know how to show a function is continuous. We know how to show a function is differentiable. In Unit 2, we learned about the derivative as a function. We learned all these connections between f, f prime, f double prime, the antiderivative, right? We've got little f, we've got f prime, we've got f double prime, we've got the antiderivative. If little f is concave up, what do we know about f prime? One more time. Little f is concave up. Little f prime is increasing. F double prime? Positive. If I tell you that little f has a relative max, what do we know about f prime? Little f has a relative max. F prime makes a change from positive to negative. If little f has a relative max, I think we also know something about big F. Little f has a relative max, meaning we went from increasing to decreasing, either smooth or sharp. That means big F had to just change from, if little f has a relative max, right, this guy or this guy, little f went increasing to decreasing, big F goes from concave up to concave down, which means big F has a point of inflection. If, for example, it wasn't big F, little f, f prime, f double prime, maybe it was, oh, I don't know, position. And then the derivative of position, you guys know, is velocity. And you took another derivative, you get to acceleration. Okay, and if I wanted to know where the position has a relative minimum, what would I look for in the velocity? Aaron, what would you look for? Position has a relative minimum. What do you look for in velocity?
Where it changes from negative to positive.
I'm sorry, what?
Where velocity changes from negative to positive.
Where velocity changes from negative to positive. And if, for example, I knew that my velocity was negative and my acceleration was positive, the conclusion there would be velocity negative, acceleration positive. Speed is decreasing. If I said velocity was positive and decreasing, you're like, what? Velocity, I don't even remember what I said anymore. We're going to have to play back the film. And kids from North Central can't see a darn thing because Steven's not interested in them, not at all. Thanks, Steven. Okay, so velocity, I think I said was positive and decreasing. If velocity is positive and decreasing, that means that velocity is positive and acceleration is negative. Velocity positive, acceleration negative, speed is decreasing. Okay, then ow, I poked myself in the eye.
It takes a talent.
I'm so talented. So crazy talented. All right, then we learn some basic derivative rules. We have the power rule. The power rule is when you have x raised to a power. And you guys know what the power rule tells you to do. When you have x raised to a power, what do?
Bring that power down.
You bring the power down. And then, oh, so awkward, you subtract 1 from the power. So one more time with me, with feeling. The power rule says, bring the power down. Oh my God, so awkward. The power rule says, just repeat it after me. I know it's Thursday morning, second period. The power rule says,
The power rule says,
if I have x,
if I have x
to a power, how do I find the derivative? Bring the power down. And? And reduce the power by 1. So you all know, for example, that the derivative of x to the 5th power is 5x to the 4th. And the derivative of x to the pi power, x to the pi. Pi times x to the pi minus 1. Pi minus 1. Now things start to get tricky when, for example, let's just add this somewhere in your notes. If I said find the derivative of the square root of x, if I were on page 5, I'm so excited. If I asked you to find the derivative of the square root of x, this is a power rule problem. The problem is you may not see it as power rule yet. I like to get it into what I call power rule ready form. Meaning I'm going to have to rewrite this as the derivative of x to a power. You guys know your exponent rules, and if you don't, it's on this pink sheet, square root of x. The way I'm going to rewrite this is x to the half. Have not taken the derivative, this is just some algebra. Now use the power rule. Power rule says,
Bring the power.
bring that beautiful power down. Bring the power down, and then subtract 1 from the power. So 1/2 x to the half minus 1, a half minus 1, you guys know, is really x to the negative 1/2. X to the negative 1/2, even better. We're going to write it as 1 over 2 times 1 over the square root of x. I can clean this up and say 1 over 2 square roots of x. I would hope for all 11 of you and all the friends watching this at home, everybody's okay? Okay. Power rule is way easy and way powerful, but often I'm going to write problems in a way that you may not see that it's a power rule problem, so you're going to use your exponent rules. Another one that's going to show up, and then I'm going to shut up so that you guys can work, and I'll stop competing with the yard crew. Derivative of 1 over x, is this x to a power?
Yes.
If it's x to a power, it's x to what power? Negative 1. Good. So I'm going to say this is the derivative of x to the negative 1, and like, take 5 seconds, finish this off. I get this is x to a power. Power rule says, bring the power down, reduce the power by 1. Negative 1, x to the negative 2 is good. Negative 1 over x squared is better. And Stephen, I was kind of been over here for a little while. Stephen, are you okay this morning? Is everybody able to see it? Okay, if not, I'm going to send them your email so that they can call you and email you and ask you all the clarifying questions.
Oh, it's.
Okay. Oddly enough, Celeste, you happen to know his information, huh?
Oh. Yeah, well, yeah.
I'm out of
we're in
here.
business together.
I'm out of here.
All right, everybody good? We've got this under control. Okay, my sloppy notation people. Sloppy notation people. I need to see that beautiful derivative symbol until you actually take the derivative. Don't tell me that, I don't know, square root of x equals this guy over here. No, this is the thing. Last unit it was the word it. The unit before was like, are you writing limits in the right places? Now I'm going to be paying attention to your notation. The derivative of the square root of x equals this guy over here. Don't tell me square root of x equals that, because right away I'm going to be like, I'm out. Be careful with the notation. Pretty good? All right, your goal, you've got the next, like, let's call it 7 minutes. See what you can do with this partner practice. I'm going to take attendance. I'm going to walk around, make sure your belt matches your shoes. Seems like an important thing. Excellent. Well done. All right. Focus. I did not pick kind questions for you all.
This is great. That's why it's
Oh my
self-limitation.
That's why you literally called me out for a reason. God, holy moly, I think you need to find different friends. 3 more minutes.
Is Are you following?
Yeah, bro, it's each square.
Where is it?
All right, spoiler alert, here comes some of the answers. At this point, my expectation is you're done with the first three. I have a master's degree, Aaron. All right, I would hope for all the friends, F prime, piece cake. Didn't even think about it. 3x squared minus 8x. You might be like, I don't even remember a time in my life when I didn't know this. Okay. Now, G double prime of t. Here comes some pickiness on my part. Notation, G prime, or G prime of t. Do not write G prime of x. I'm not interested in G prime of x. Negative 2t cubed plus 9t squared minus 2. G double prime, take another derivative, so G prime prime. Negative 6t squared plus 18t. Pretty good? All right. What on earth, Andrew, does this notation over here mean? dh d theta slash theta equals 1? What would that mean?
To find the derivative of the function of h.
Find the derivative of the function of h. Now I'm being a little bit wacky here because now for some reason I'm using theta as my variable, but guess what? Take the derivative in the same way. And then that little vertical bar means?
When you find the derivative, to plug that into the...
Andrew, I love what you said. After you have found the derivative, then you plug in 1. This is a two-step process. I need to see both steps, Aaron. I want to make sure you heard that. Two-step process. Step 1, find the derivative. The derivative is 8 theta minus 3. Show me the derivative. Do not write h prime of 1 equals 8 theta minus 3. H prime of 1 is what you get when you plug 1 into the derivative, and you're going to get 5. All right. This is the last one I want to make sure that we talk about. No, that's a lie. 4 and 5. If you haven't done 4 and 5 yet, take another 2 minutes. We'll talk in 2. If you made it past 4 and 5, great. But I care greatly about 4 and 5. So picky with the notation. So picky. Good. Not done. You're not done. Horizontal tangent line. How would you find a horizontal tangent line? What do you know about the derivative at a horizontal tangent line? Nice. If the original function has a horizontal tangent line, so you found the derivative. Give me the roots. Friends back here, okay? And found the derivative, h prime. Now I just want the roots. Love. Easy peasy. Doing okay? Plus or minus 0? I only know one flavor of 0. Serious, you're cracking it up.
Say that as the teacher walks up.
No.
The stupid one. I was here and I heard it.
Yeah, I was like, it's not there. Yeah.
Alrighty, friends, I had a chance to walk around. Here's the thing, I loved what I saw on Giselle's paper. She solved this problem the exact same way I did. Aaron, if I'm looking for a horizontal tangent line for h, she made a little note on the side that said h prime of x has to equal 0. That's the key. Everything falls from there. So I'm going to find h prime of x, 5x to the 4th minus 15x squared. I'm going to set this equal to 0, and I'm going to make my Algebra 2 teacher proud. 5x squared is equal to 0 when x equals 0, or as Lewis likes to say, plus or minus 0. X squared minus 3 is equal to 0 means x equals plus or minus square root of 3. Everybody good? Alright, number 5. Particle travels along the x-axis in a way that its position can be determined by that equation. Determine whether the speed of the particle is increasing or decreasing. How would I ever, Myra, how would I ever make a decision about speed increasing or decreasing? What would you do? You find the derivative of the position function, which is going to be velocity. Why would you do that? I agree that the absolute value of velocity is speed, but if I'm going to make a decision about speed increasing or decreasing, there's two things that we need here. Lewis, what are the two things?
Acceleration and, and velocity.
And velocity. So first, we're going to find the velocity function, 18t to the 5th minus 30t. Then we're going to find the acceleration function, 90t to the 4th minus 30. Showing me that you found both of these functions, making sure that you've labeled them correctly, probably worth a point to get you started. And now I need to see that you actually evaluate velocity at 1 and acceleration at 1. Let's see, velocity at 1 is a negative number. Acceleration at 1 is a positive number. Conclusion? Speed is decreasing. Oh, everyone stopped talking. And everyone stopped earning points.
At t equals 1.
At t equals 1, speed is decreasing. Otherwise, what you all said to me was speed is decreasing everywhere. Speed is decreasing at t equals 1. Are all the friends okay? All right, good. All right, so here's how we're going to spend the rest of the day. Rest of the day, we are just going to play around with some different derivatives. All of these are going to mess with your heads at least a little bit. Because right now, all you know is the power rule and like constant rule and things like that. No one yet, except maybe Stephen in his Googling hours, knows about product rule, quotient rule, chain rule, derivative of sine, cosine, tangent. They're not even on the sheet. No one knows about the derivative of the exponential, or the logarithm, or the inverse tangent, or the arc secant function, or the hyperbolic functions. Okay, I went a little crazy there. Yes, there are things called hyperbolic functions. No, we are not going to study them. I will save that for your Calculus 2, Calculus 3 professors. Just know, though, I could do it if I needed to. All right. All right, so friends, here's what we're going to do. I want to do a couple of these together with you and then give you guys some time to practice. For those of you that are gifted in the way of the derivative, feel free. Do go as far as you want without me. You don't need me. A problem we're going to run into, though, is this. Right now, the only thing you know is the power rule. The power rule tells you what to do when you are taking the derivative of x to the power, and you guys have already told me, n times x to the n minus 1. That's all that we know. For example, something like 2x cubed minus x, the whole thing squared, is too much. It's too much for the power rule. Unless you see some clever algebra that you can do. Does anybody see some clever algebra that you could do that would allow you to use things like the power rule, the sum rule, the difference rule. And it's going to be algebra first, then some calculus here. If f of x equals 2x cubed minus x, the whole thing squared, a legal thing that you could do, David?
Distribute the exponent.
Now, I heard you say distribute the exponent. My fear is that what you're thinking is 2x cubed gets squared, negative x gets squared.
2 squared.
All right, and I'm going to do that work over here. This is, and I want to be really careful with my labeling, friends. Right now, I am not actually doing any calculus. This is derivative, this is algebra stuff, right? The function was named f, the function remains f. Why are we doing this? Because David knows, I multiply out 2x cubed minus x and 2x cubed minus x, we can do the box.
Sure.
Most of you guys can probably do this in your head now. What are we going to get?
4x to the 6th power
4x to the 6th power.
minus 4x to the 4th power.
Should be minus 4x to the 4th power
Plus x squared.
plus x squared. Now be careful with the labeling.
Yes.
Still f. Have not taken a derivative yet. Now my question for you all is everything written as a power of x?
Yes.
Yeah. Now, I'm adding and I'm subtracting, but we know how to do that, right? We can distribute the derivative. I'm multiplying by constants, but I think we know what to do there. So it's like take 5 seconds, get me the derivative. And I'm going to do the derivative in that last column so it's super clear. If f of x is 4x to the 6th, the derivative over here is 4 times 6x to the 5th minus 4 times 4x cubed plus 2x. Hopefully everybody's got 24x to the 5th minus 16x cubed plus 2x. Easy peasy.
Yes.
Here's the thing though. Because the only thing I know are things like power rule, sum rule, difference rule, and constant rule, I can't handle this function the way it's presented. I needed to do the algebra first, then hit it with the calculus. Okay? Have a strategy conversation about this second one. What would you do? Looking for legal algebra.
You're going to multiply the x cubed. Okay. Oh, x cubed. That's all.
Legal algebra only. Multiplying by x cubed is not an example of legal algebra. I understand why you're multiplying by x cubed, but the problem is if you multiply by x cubed, that is not the same as multiplying by like x cubed over x cubed, which would be like fancy 1. Multiplying by 1 is legal.
Oh yeah, I forgot because when I say x cubed, I mean like top none, but I just say like multiplying by x cubed. Like I just put it in do both. Like I naturally do both.
Okay.
I regret having to say this.
All right, I've seen two options. I've seen some folks that said, you know what I'm going to do is I'm going to make this 5x cubed minus 3x squared plus x, and I'm going to multiply by x to the negative third. First, is that legal?
See. Wait, what did you say?
Yeah, you might want to look. Is that legal? That's always the first question. Is this legal?
I mean, yes.
Stephen, why is it legal?
I mean, all you did was just, I guess, reverse like the x cubed and put it on top of the
5x cubed minus 3x squared plus x divided by x cubed is the same as saying multiply by x to the negative third. Because negative exponents just say, put this in the denominator. Legal. Why would this be better? Palamon, why is this better?
It's better because it's generally just less work, just moving from the bottom to the top.
Okay, but why is this going to get me into something I can find the derivative of with the power rule?
Oh, you can do.
Now that I've got multiplication, how about distribute? Right? I know I've got the x to the negative third at the end, but I can distribute in this direction too. 5x cubed times x to the negative third. That's why you've got that exponent sheet if you need it. 5x cubed times x to the negative third. The bases are the same and the rule with the exponent here. 5x cubed times x to the negative third. Shouldn't that be 5x to the 0 power? The bases are the same, we add the exponents together. And you know what x to the 0 power is? 1. Okay, minus 3x squared times x to the negative third, x to the negative 1. X times x to the negative third is x to the negative 2. My question for you all is, are we in power rule ready forms? Right. Over here I wasn't because I'm doing division. I don't know how to do that yet. That's tomorrow. Don't be absent tomorrow, Aaron. Okay, all I'm doing is rewriting this so that legally I can clean this mess up. And maybe, Andrew, you're like, hey, wait a minute, before I even take a derivative, x to the 0 is 1. So isn't this really 5 minus 3x to the negative 1 plus x to the negative 2? Sure, still algebra. Haven't taken a derivative. Take 30 seconds, get me the derivative, and get me the simplified version of the derivative. Be careful here with the signs.
Oh, I see what you're saying.
Give me a quick thumbs up if you agree with what I've got here. Y prime, I've got 0 plus 3x to the negative 2 minus 2x to the negative third. I like that. The way I'm more likely going to show this on something like the unit test, I'm going to push you to like re-express using without using negative exponents. 3x to the negative 2, 3 over x squared, negative 2x to the negative third, negative 2 over x cubed. Everybody good? All right, see what you can do with 3 and 4. We'll talk in a little bit. Yeah.
So when you get into the order of everything in this right?
If you wanted to, that's fine too. So like rearranging them, so like the negative 2 over x cubed comes first, and then plus 3x squared, that's fine. Algebraically, it's
I'm just used to keeping it that more.
okay. Gotta keep it tight. Nice, we get some good exponent stuff happening here. 1 over the square root of x. Everybody seems to have this written as x to the negative half. This is algebra first, and I'm going to keep switching colors. G prime then. G prime, Ailey, what do you have for G prime?
Negative 1/2.
Negative 1/2.
X to the power of negative 1.
Okay, think about the power rule. Power rule says bring the power down, and then reduce the power by 1. So you already have negative 1/2, reduce that by 1. Negative 3 over 2. So negative 1/2 x to the negative 3 over 2. I like this as an answer. This is probably not how I'm going to show it on the unit test. I'm going to hide this from you. College Board is going to hide this from you. Myra, do you see how the College Board might hide this from you? What could they do? And if you're not sure, you're not sure. Okay, somebody help her out. How might the College Board hide this from you? David sees it, Lewis sees it, Hollyman sees it. How else might the College Board represent this answer? They're going to mess with your head. You did all good work, and they don't show this as the answer. David, what are they going to do?
They might write it as negative 1 over 2 x square root of it.
Okay, x to the negative 3/2, they're going to send it to the denominator.
Yeah, x squared root of x.
So maybe you're like, oh, it's going to be like that. Yeah, maybe.
But then you're going to do the square root.
You're going to cube the square root of x, right? So you've got negative 1 over 2 square root of x cubed. That is more likely how they're going to write the final answer. Yep. This is a perfectly legit, fully correct answer. Free response, this is good. Multiple choice, this is how they're going to see it. All right, let's do this one. H of x equals x times the square root of x. If If I want to use my algebra skills, how about x times, what is this, x to the 1/2 power? Okay, x times x to the 1/2 power, you guys all know what that is.
Well, this is X.
Right, this is x to the 3/2. Again, I'm going to use equal signs because all this is equal to h of x. H prime though, h prime, take that derivative, bring the power down, 3/2. X to the 1/2 power, even better. 3/2 times the square root of x. Everybody's good? All right, with this, I want to stop talking. I want to do a quick skim of your multiple choice results. There are 1, 2, 3, 4 problems that are going to challenge even the brightest minds in the room. See what you can do. All of these need to get to derivative ready form.
Yeah, like when you move it up, it should be 6 X negative. Because there's X is separate from 6. Yeah, it is because you write it out. You can write it out like this. No, it's 8.
Aaron, you're not the dumb one. We've already established. She'll ask you know where to tell us. She's like, you're both mad. I don't know anything.
What do we think? Okay.
Don't put that. If you're gonna move it to the side, you can't choose this here. So I'm saying you have to put it on 8x negative 3. Because you put it, you cube it. If you cube it, you move that up. You know what I'm saying? So if you cube it, you can't put that versus the 8.
Why do so many of you have difficulties choosing the letters that are listed? What do you mean?
Oh, like C, like people
Like C and people are writing H and I'm having to like code switch in my brain here?
No, I checked it.
Celeste, I'm actually talking about you.
Dang it. No, it didn't. You checked it out. I don't think it did. I think it's like
What? You got this, right? No.
yes.
How'd you get her 2.18?
Underneath the power.
No, I know 8, but like why did it like
1.
No,
Wait,
I'm
oh.
talking about this.
No, I know. But like how do you get from this to this? Okay, I know this.
Cube this, right?
Yeah, that's
And you cube this. If you put it like this, you cube this.
yeah.
You still, but you already did it, so you don't have to.
Because it's okay. Oh,
Well,
You
you already got, you already done it. You already should. What is it? you can actually repeat and do that.
Oh, yeah.
Repeat it, do that. Just do it, put it on the denominator. So you do that.
Can you cancel out for cancel out?
that's what I hope.
So 8x negative.
For K.
You guys don't share.
We know.
That's
why we sit here.
Just don't put parentheses in your
What I'm saying, the reason you would do that is the reason
You don't.
Did you get it?
Your explanation is so far. You missed what?
Don't worry, I'll get her on the free response.
You already did it down. You missed nothing.
You going?
You just wrote it, because you can write that 8x and say the key, or you can write it without parentheses. You can write it. You can write it like that, so once you write it like that, you don't need the parentheses anymore. So you wrote it.
when it's like 8, 7,
Oh, yes.
I don't know.
Please explain this thing. Because it made me frustrated. You frustrated.
I'm frustrated myself.
I thought it was good though.
This is little thing that's harder than
It might be.
Created it, talk to people, less than 5 minutes, smart, good looking, and fast. Oh, I didn't set the timer. Okay, yeah.
Oh,
I'll ask you.
okay.
4 minutes X to you, cancel out X minus
No,
4
no,
X
no.
plus 4. Making a small.
Take out a
Or
Yeah, it's
on the ball. Where you choose.
You could that be equal to negative
the negative aspect. The negative exponent.
to the whole equation.
Yeah.
Then you cancel with this one. Or X plus 4.
All right, friends.
So you take out.
All right, so number 6, stay with me. A way to rewrite this is to cube the denominator. 2x times 2x times 2x, 8x cubed. But here's the thing, that 8x cubed is still in the denominator. Now, if I was going to rewrite this, what I need is for the variable to come out of the exponent. So I could think about this in a couple of moves. How about 1 over 8 times 1 over x cubed? Is that legal?
Yes.
Right, and that's the same thing here? So then j of x is 1 over 8x to the negative 3rd power. The 8 stays in the denominator because I'm just going to represent this as 1/8. Now what's the derivative? J prime is 1/8 times negative 3 x to the negative 4 power, which even better. Negative 3/8 x to the negative 4 power, even better. Negative 3 over 8x to the 4th. How many guys honestly had that as your answer? Negative 3/8 x to the negative 4. Myra, did you get that? Okay, questions on this one? Everybody good? All right, number 7, x squared minus 16 over 4 minus x. Oh, we need some clever algebra here. X squared minus 16 over 4 minus x. Think about some algebra here. Lewis, what could you do?
You factor the X squared minus 16.
Okay, first, I'm gonna keep asking the same 2 questions again and again. Number 1, is this legal? Is factoring legal?
Yes.
Yeah. X plus 4 times x minus 4 over 4 minus x. Legal. Is it better? Does it get you closer to a final answer? Yes, Celeste, how does it get you closer?
You cross out x minus 4 on the numerator and 4 minus x on the denominator, and you get k of x equals negative x.
There, okay, good save. So These guys, they do cancel, but not in the traditional way, right? These are actually opposites of each other. So you're saying it's x plus 4 times -1, which even better is negative x, negative 4. The derivative then has to be? What's that derivative? Derivative of negative x, negative 4. Uh-oh. Okay, let's go through the process here. Is this a power rule? If it's a power, it's because you know what the power is. The power is 1. What does the power rule tell you to do? Bring the power down, leaving, and then reduce the power by 1. So you've got -1 x to the 0 power, derivative of negative 4. 0 because it's a constant, so you're going to get -1. K prime of x is -1. All right, number 8, just a whole bunch of ugly fractions. Right, L of x, you guys know, instead of writing this as square root of x, we're going to write x to the, what is that, x to the half? Cube root of x, better way to write that, is x to the 3rd. 1 over the square root of x, better way to write that, is x to the -1/2. I cannot emphasize enough how lethal I am picky I'm going to be about the notation. This is still L. You haven't found L prime. L prime is the next step. I think a lot of you guys didn't get to this, so finish it off. Get me that most likely multiple choice answer. Right, Aaron, these guys, they're not like terms, so you can't combine them. If it was a positive x to the half and a negative x to the half, the exponents are different, so they're not like terms, you can't combine them. Right, I'm gonna keep switching the name of the function on you, so slow you down and make you focus. All right, Andrew, what's the derivative of x to the 1/2 going to be?
1 over x, 1 over square root of x.
X to the 1/2, we're going to bring that power down in front, so let's do this one step at a time. That's going to be 1/2 x to the, reduce the power by 1. 1/2 minus 1, -1/2. David, derivative of x to the 1/3 power.
1/3
Plus 1/3.
x to the power of -2/3.
1/3 x to the power of -2/3. And derivative of x to the -1/2. What's that going to be? Lewis, what you got?
-1/2 x to the
-1/2 x to the -3/2. I like it. I love it. Let's come back and reduce this and use proper exponent rules. 1/2 x to the -1/2, x to the -1/2, send it to the denominator. Because this is x to the 1/2, this is going to be 1/2 times the square root of x. X to the -2/3 power, hey, negative exponent again, send it to the denominator. There you're going to have 1/3 cubed root of x squared. X to the -3/2, send it to the denominator. I'm going to have -1/2 square root of x cubed. This answer is perfectly acceptable, but knowing the multiple choice, this is how they're going to push your thinking. This is how I'm going to push your thinking too. I'm going to hide it from you. Everybody good? All right, one last one that I want you guys to dangle with for a little bit, because I don't think anybody made it to number 9. You remember what it is?
Yeah.
Okay, but I want you to see if you can prove it. Okay, just quick show of hands. How many of you guys remember what the derivative is? One person? Two? You remember what the derivative is? Okay, if you don't remember what the derivative is, absolute value of x looks like this, right? Think about what happens with the slope over here. Think about what happens with the slope over here. Think about the cusp point. I think a lot of folks just had the flash, or like, oh, I remember what this is. What's the derivative? What does it have to be? It's the absolute value of x over x, right? It looks like this. Now, what's just happened over there? A way to think about this, and I think this one's really tricky. Right, you guys all know what the graph of the absolute value of x looks like. And back in Algebra 2, there was another way to write the absolute value of x that involved a piecewise function. How do I write this piece? This is just y equals x. This piece over here is negative x. So if I want to rewrite m of x equals the absolute value of x, I can say, oh, it's negative x for x less than 0. It's going to be positive x for x greater than 0. And what happens at x equals 0? Just 0. This is not by any stretch of the imagination an obvious thing that I think most of your brains would naturally go to. Right? But I hope we're okay with the next piece. So let's take the derivative. The way I take the derivative of a piecewise function, one piece at a time. The derivative of negative x. The derivative of negative x has to be negative 1. So this is negative 1 if x is less than 0. The derivative of x is 1 for x greater than 0. Now, what happens at x equals 0 on the graph of m? What happens over here? You have a cusp point, which means that at x equals 0, your derivative does not exist. So what I need is I would need a graph, and you guys know the story. I need my graph to be equal to negative 1 for x less than 0. I need it to be positive 1 for x greater than 0. And what this is the graph of the absolute value of x over x.
Wait, so we have to use a graph to show that answer?
No, not necessarily. I would accept this as a great final answer.
Okay.
If you're able to sort of pull everything back together into this absolute value of x over x form, that's great too. In calculus, the way that we're going to normally handle taking the derivative of the absolute value of a function is we're actually going to break it up into a piecewise function. Because then with each piece, you don't need the absolute value bars, you just get something that you can take the derivative of. Okay? Tonight's homework is lesson 38, the assignment for lesson 38, round 1. It's probably going to take 15 minutes max. Smart thing to do, get it done tonight. I would also organize your binder. If your binder has like 15 pounds of paper in the cover, you might want to clean things up a little bit. I would get rid. God, David, why can't everyone's binder be as beautiful as yours is?